Today we are going to start our next expression of concentration, in which we will deal with the topic molarity, right? Hello everyone, in the previous part of the topic concentration we have discussed mass by mass, volume by volume and mass by volume, these three expressions of concentration. Today we are going to start our next expression of concentration, in which we will deal with the topic molarity, right? So I am going to start this topic molarity. This will be the fourth expressions in which we can show the concentration term, right? Molarity. All these expressions, what the information they provide, it is the amount of solute that will be present in a particular amount of solution, right? So similarly, molarity also provide the information regarding amount of solute that will be present in a particular amount of solution, obviously, right? So what is the information that we can have from molarity, my dear friends? Please listen. It tells about moles of solute present in 1 liter of solution. Okay, the formula for this term, for this expression, molarity is equal to moles of solute upon volume of solution, in liter. So what will be the unit here? Unit for molarity, my dear friends. So you can see that moles of solute, right? Moles of solute. So in the numerator it will be moles. Now volume of solution in liter. So mole by liter. So I can say mole by liter or mole liter inverse, or I can say capital M. These are the possible units for the term molarity, right? All have same meaning. So listen, what is the information? In actual, what is the information we are going to have from this expression? Listen, there is a solution whose molarity, is given as 2 mole per liter, 2 capital M, 2 mole per liter or 2 mole liter inverse. So I am going to write 2 mole per liter, my dear friends. 2 mole per liter, mole liter inverse or mole per liter, right? It is the unit. So what is the meaning of this per tells, that means 1 liter, that means 1 liter. If you will take 1 liter, there is a solution who is having molarity 2 mole per liter, and if we will take 1 liter of this solution, so that 1 liter of solution is going to contain 2 moles of solute, right? If you will take 1 liter of this solution, that 1 liter of that particular solution is going to contain 2 moles of solute, right? So listen, I can write that 1 liter of solution contain 2 moles, or I can say that, because 1 liter is equal to 1000 ml now. 1 liter 1000 ml all are same thing. So I can say that 1000 ml of the solution contain 2 mole. My dear friends, ml is also known as cc or centimeter cube. So I can say that 1000 ml or 1000 cc or 1000 centimeter cube. Remember what? 1000 ml or 1000 cc or 1000 centimeter cube. If you will take such amount of such volume of the solution, whether it is 1000 ml, whether it is 1000 centimeter cube, whether it is 1000 cc, all are same. So it will contain 2 mole of solute, right? See, my dear friends, listen, there is a solution. If molarity, suppose you are having molarity now, in this case 4 mole per liter, my dear friends, 4 mole per liter. So what I am going to tell you, listen please, that means 1 liter of solution contain 4 mole na, 4 mole of solute. Obviously I am going to talk in terms of solute, right? About solute, right? So 1 liter solution contains 4 mole, right? So I can write 1000 ml of solution contain 4 mole, right? Both the same thing, my dear students, because 1 liter is equal to 1000 ml, right? Now listen, if in question it is asked about, suppose about 500 ml, it is a question that if you will take 500 ml of a solution whose molarity is 4 mole per liter, what will be the amount of solute that will be present in that particular amount of solution? If you will take 500 ml of a solution whose molarity is 4 mole per liter, then what will be the amount of solute present in that particular amount for 500 ml, right? So listen, my dear students, if 1000 ml having 1000 ml having 4 mole of solute, 1000 ml having 400 of 4 mole of solute. So now you have taken just half amount, that means you have divided by 2, right? So obviously it will be also divided by 2. So that means 4 upon 2, that means 2 mole of solute. That means if you will take 500 ml of a solution whose molarity is 4 mole per liter, then that particular solution will contain 2 mole of solute, right? Suppose it is a question, my dear students, you are going to take 200 ml of that particular solution, right? So listen, my dear students, here you have divided by 5, because if you will divide 1000 by 5, so obviously you are going to get 200, right? And obviously in this case also, if you have divided here by 5, so obviously you are going to divide by here 5 also. So 4 divided by 5, 5 8s are 40, so 0.8, 4 upon 5 will be equal to 0.8. Now my dear students, listen, about if I am going to take 100 ml, that means this is just divided by 10, it is going to divide by 10 also, because in left side you have divided by 10, so obviously in right side you are also going to divide by 10. 4 divided by 10, that means 0.4 mole of solute. This will be the amount of solute that will be present. In this way you can solve this question. If someone asks you about 50 ml, suppose 50 ml, so if you can see that if 100 ml having 0.4 mole, so obviously half of this will have half of this amount of solute now. If 100 ml having 0.4 mole, so half of this will have half of the amount of the solute, half moles of the solute. I hope it is clear to you. Now suppose if you are not able to solve in this way, my dear students, if you are not able to solve in this way, suppose you are not able to solve in this way, I will suggest you that you should solve in this way, and you will be able to find the answer very instantly without any it is calculation actually, but very instant calculation, right? But suppose you are not able to solve this problem, this calculation in this way, then what you will do, you will write that, suppose you want to calculate for 200 ml, right? 200 ml, and the molarity is given as 4 mole per liter. So you will write is molarity is 4 mole per liter. So that means you can write that 1000 ml or 1 liter, 1000 ml contains 4 mole of solute. So 1 ml will contain 4 upon 1000 mole of solute. So 1000 ml containing 4 mole of solute, so 1 ml will contain 4 upon 1000 mole of solute, and you want to calculate for 200 ml. So 200 ml will contain, right, 200 5s are 5 8 4 5 8s are 40 na? So 0.8. So 0.8, same answer you are going to get, same answer, right? So in this way you can also show that 1000 ml provide this amount of solution, 1000 ml contain this amount of solute, moles of solute, and so obviously 1 ml will contain this mole of solute, and obviously whatever the amount of whatever the volume you want to calculate, you just multiply by that value and you will get the moles of solute in that particular amount. That is all about that. Now my dear friends, question are like that. calculate number of moles of solute in A part is 300 ml of 2 capital M solution. B is, listen, B is 200 ml of 4 capital M solution. These are the two questions. My dear students, how to deal with these problems? Listen please. You have to calculate the amount moles of solute, right? And this is the information it is given, that we in the first case we have taken 300 ml of a solution whose molarity is 2 mole per liter. In the next case we have taken 200 ml of a solution whose molarity is 4 mole per liter, right? Now my dear students, if molarity is 2 mole per liter, that means in 1 liter it is having 2 mole of solute. So I can write in 1 liter, or I can write 1000 ml contain 2 mole of solute. So I am not having any idea that how, by which value I am going to divide to 1000 and I will get 300. There is no such value that by which I can divide 1000 and I will get 300 value. There is no value, right? So what I am going to do, listen my dear students, I can calculate for 100 ml, divide by 10 divide by 10. So obviously if 2 will be divided by 10, so that means 0.2 mole you are going to get, right? 300 ml. So obviously 300 ml will have, if 100 having 0.2, so and now you are going to take just triple amount of this, that means you have multiplied by 3. So obviously here you are also going to multiply by 3. So 3.2 multiplication, it will become 0.6 mole. So this will be the right answer for this question. 0.6 mole of the solute will be present in 300 ml of a solution whose molarity is 2 mole per liter. That was about that. Now my dear friends, if you will take 200 ml of a solution whose molarity is 4 mole per liter, so if molarity is 4 mole per liter, that means I can write 1000 ml contains 4 mole of solute. So so you want to calculate for 200 na? So 200 ml will contain, my dear friends, you are going to divide here by 5, because if you will divide 1000 by 5, so you will get 200. So obviously this will also be divided by 5. If 4 divided by 5, so you are going to have 5 8s are 40, that means 0.8 mole of solute will be present. I hope this is clear to you, right? Now my dear students, suppose you have a question, you just calculate the moles of solute in 1500 ml of solution of a 1 capital M solution, right? D is calculate the number of moles of solute in 3 liter of a solution whose molarity is 2 mole per liter, right? So how to solve this problem, my dear students? See, we will have to calculate the moles of solute in 1500 ml of a solution whose molarity is 1 mole per liter, right? So listen, 1 mole per liter na? So that means I can write 1000 ml contain 1 mole solute, because 1 mole per liter na? So 1500, my dear students, you can see that you are going to multiply by here 1.5. If you will multiply 1000 by 1.5, so you will get 1500. So if in the left side you have multiplied by 1.5, so obviously in right side you are going to multiply by 1.5. So 1 into 1.5, 1.5 mole of solute will be present. right? Now my dear students, it is 2 mole per liter, that means 1 liter will contain 2 mole of solute. I can write 1000 ml or I can write 1 liter, because I will have to deal in the terms of liter now. So that's why I have written 1 liter. So 1 liter contain 2 mole of solute, so 3 liter will contain, you have multiplied here by 3, so obviously you are going to multiply here by 3 also. So 3 to the 6 mole of solute will be present if you will take 3 liter of a solution whose molarity is 2 mole per liter, right? Now next step, A, B, C, D, E, right? You have taken 200 ml, you have taken 200 ml of 1 capital M solution plus, and you have added it with 100 ml of 2 capital M solution, right? A, B, C, D, E, F. You have taken 300 ml of 2 capital M solution and you have added it with 200 ml of 1 capital M solution. So my dear students, please see how to solve this problem. You have taken 200 ml of 1 capital M solution and you have added it with 100 ml of a solution whose molarity is 2 mole per liter. I am talking about E, so E part or E anything, right? E part of the E part, right? So 200 ml of 1 capital M solution and you have added it with 100 ml of 2 capital M solution. Listen, I will calculate moles of solute in the first solution and then I will calculate the moles of solute for the second solution and then I will add both of these values and I will get the right answer. I will calculate moles of solute in the first solution, I will calculate the moles of solute in the second solution, then I will add the moles of solute in both the cases and then I will get the total moles of solute that will be present right now. So listen, if molarity is 1, now I am going to solve moles of solute in the first solution. It is a mixture of 2 solutions. Na? So for first solution, if molarity is given 1 capital M, so that means if I will take 1000 ml, so in 1000 ml there will be 1 mole of solute, and if I will talk about 200 ml, so obviously I am going to divide by 5 now, because if you divide 1000 by 5, so obviously then in that case only you will get 200 ml. So here you will also divide by 5, so 1 by 5, that means 0.2 mole of solute will be present here. Now my dear students, 2 mole per liter, the molarity is given here. So 1000 ml contains 2 mole of solute. So and I want to calculate for 100 ml. So obviously you are going to divide by here 10. Na? You are going to divide by here 10 also. If in left side you have divided by 10, so only in right side obviously you are going to divide by 10. So 2 by 10, 0.2 mole of solute will be present here, right? So my dear friends, 0.2 mole from this side, 0.2 mole from this side, so 0.2 plus point, that means 0.4 mole will be the total amount of solute that will be present here, right? Barabar hai? Now my dear friends, see, 300 ml of 2 capital M solution, 200 ml of 1 capital M solution, and these both solution have mixed. Now please see, I will calculate moles of solute in the first solution and I will calculate moles of solute present in the second solution. I will add moles of solute in both the cases and I will get the right answer. Listen, if 2 mole per liter, that means 1000 ml or 1 liter, both are same thing. 1000 ml contain 2 mole of solute. I want to calculate for 300 ml, but I do not have any value by which I can divide to 1000 and I will get 300. So what I will do, I will calculate for 100 and then I will multiply by 3. So if 1000 ml contain 2 moles, so obviously 100 ml will contain, I have divided by 10, so it will be also divided by 10, so that means 0.2 mole. and I want to calculate now for 300 ml. That means it is multiplied by 3. Obviously it will be also multiplied by 3. 0.2 into 3, that means 0.6 moles of solute will be present in the first solution, right? Now I am going to talk about second solution, my dear students. For second solution, listen, it is 1 mole per liter. 1 mole per liter molarity is given for the second solution. Listen, if 1000 ml, 1 molarity, so 1000 ml will contain 1 mole, na? 1 mole of solute. Now you are talking about 200 ml. That means it is divided by 5, so obviously it will be also divided by 5, 1 by 5, so it means 0.2 mole. 0.2 mole, 0.6 mole, it will be added 0.8 mole. Now listen, this was the question that calculate number of moles of solute, right? Suppose the question is that, now we have solved all these things in this way, we can solve, right? Suppose, my dear friends, in the first case the solution the question becomes, right, that like that calculate molarity also. Then in this case you know the moles of solute, total moles of solute. So molarity for this case, obviously molarity is equal to total moles of solute upon total volume of solution, right? And you have known that what is the total number of moles of solute now? 0.4. So in place of this total moles I am going to replace it 0.4. And what is the total volume, right? It is a mixture of two solution. Volume of the first solution is 200 ml, volume of the second solution is 100 ml. So 200 plus 100, obviously the total volume will be 300 ml, right? So 300 ml, now you will have to take in terms of liter. It is 300 ml, na? So meaning of milli is 10 to the power minus 3, so it will become 0.3 liter, right? So you are going to put here 0.3, you are going to solve this and you will get molarity of the final solution, right? Now if you want to calculate molarity for this mixture of two solutions, so obviously molarity will be equal to total moles of solute, that is equal to 0.8, right? So 0.8 upon volume of the total mixture of this solution. It is now another solution, now new solution, right? So the volume of this mixture will be 300 plus 200, because this is a mixture of first solution and second solution. So obviously for knowing the volume of the mixture you are going to add the volumes of two different solutions, right? So 300 plus 200, that means 500 ml and it means 0.5 liter, right? So obviously 0.5 liter you are going to solve, you will get the answer, right? So this was the way in which we can calculate the moles of solute in a particular amount of a solution whose molarity is given to you, or you can calculate the moles of solute in a mixture of two solutions, right? Now we will discuss the different type of questions. Yes. So the question is 30 gram CH3COOH, right, is present in 1500 ml of solution, right? So calculate molarity, right? It is a question, and we know that the formula for molarity is equal to number of moles of solute upon volume of solution in liter. So number of moles of solute, we do not have moles of solute, we have amount in grams for solute, right? We have amount in grams, right? So which is equal to 30 gram, and we know how to calculate number of moles. Number of moles is equal to amount in gram upon molecular mass. What is the molecular mass of CH3COOH? CH3COOH. C, 2C here, 2 carbon atoms are here and 1 carbon having atomic mass 12, so 2 atom will have 12 into 2, that means 24. here 3 plus 1, 4 hydrogen atom are here, one having 1 atomic mass, so 4 will have 4 into 1, that means 4 atomic mass here, plus oxygen, 2 oxygen are here, 1 oxygen having 16 atomic mass, so 2 oxygen will have 32 atomic mass, right? It will be 60. So number of moles of the solute, that is solute is CH3 right? So number of moles will be amount in gram 30 upon molecular mass, it is 60, so 0.5 moles will be there. And now I am going to place here number of moles upon volume of solution, right? Volume of solution, right? So number of moles 0.5, volume of solution in liter, you will have to take in terms of liter, it is 1500 ml, right? So obviously you will divide by 1000, you will get say 1.5 liter, right? So 1.5 liter, 0.5 upon, that means 1 upon 3, it means 0.33 mole per liter or capital M, right? Now next question. These are the formula based question that you can solve. If you have the volume in terms of ml, so you will change in terms of liter. And if you do not have moles of solute, so first of all you will calculate the moles of solute by using the formula number of moles is equal to amount in gram upon molecular mass, and right. The question is that now the question is, when we will require the term density, right? So I am going to introduce the term density in the questions of molarity now, right? So listen my dear friends, this is the question, and I have discussed about term density in the first part of the topic concentration, so you can check the previous video, right? 2 moles of solute are present in 1100 gram of solution, right? Calculate molarity, and given that density is equal to 1.1 gram per ml, right? Density is given here, so obviously we will require density. So the formula is, for molarity, formula is number of moles of solute upon volume of solution in liter. So listen my dear students, number of moles of solute are required, and here 2 moles of solute are given, right? So I will replace this term by 2, right? Now I will require another thing, that is volume of solution in liter. Do I have volume of solution in liter? I do not have volume of solution liter. It is 1100 gram, so it is given in terms of grams, so obviously it is amount, it is mass, it is not volume, right? It is mass. So listen, I am going to calculate the volume by using density. It is mass now, so I cannot write mass in place of volume, I will have to calculate volume by using density, right? So density is equal to mass by volume. So density is equal to mass by volume, density is 1.1, mass is 1100, volume, right? So volume will be equal to 1100 upon 1.1, so it will be equal to 1000 ml. You will get this term in terms of ml. Why? Because density is given in terms of ml, right? So 1000 ml, but you will require volume of solution in terms of liter. It is in terms of ml. So obviously you are going to divide by 1000, that means 1 liter. So 1 liter. So 2 upon 1, that means 2 capital M. 2 capital M will be the molarity for this solution, right? So next question, other question may be like, okay, listen this question. How many grams of ethanoic acid, CH3COOH, ethanoic acid or acetic acid, should be added to water to prepare 500 ml of 3 capital M ethanoic acid solution. Here ethanoic acid is mentioned, and I have told you, if about any chemical you having any formula, you having any name, so obviously it is given about solute, right? So solute is ethanoic acid here, that is CH3COOH, right? CH3COOH is solute here, right? Now see the solution. It is the question that we want to prepare 500 ml of a solution, and we want to prepare 500 ml of a solution and the solution of ethanoic acid, and the molarity of that solution should be 3 capital M. That means if I will take 1 liter of that solution, it should contain 3 mole of ethanoic acid, and I want right, this is a molarity, 3 mole per liter, and I want to prepare 500 ml of such solution. I want to prepare 500 ml of a solution whose molarity is 5 capital M, and I want to take solute, I want to take acetic acid or ethanoic acid as solute, right? So see, solution 3 capital M, right? So if 3 molarity is given, my dear student, if molarity is given as 3 capital M mole per liter, that means 1 liter, or I can write 1000 ml will contain 3 mole of solute, because the molarity is given 3 mole per liter. Huh? So 1000 ml will contain 3 mole. So, and I want to prepare 500 ml. No? So obviously 500 ml will contain, you have divided by 2. Obviously in this case you will divide by 2. So 3 by 2, that means 1.5 mole. 1.5 mole, right? So that means you will require 1.5 mole of solute, and solute is ethanoic acid, that means you will require 1.5 mole of ethanoic acid. Now you will require 1.5 mole of ethanoic acid. Now the question is being asked, how many grams? That means you are not going to tell that how many moles. Moles is 1.5 mole, you can calculate very easily, but the question is how many grams of ethanoic acid. So I have told you that number of moles of solute is equal to amount in gram upon molar mass. We have seen that the molar mass of acetic acid or ethanoic acid is 60 gram per mole. Now number of moles, we have 1.5 number of moles, amount in gram you will have to calculate, and molecular mass is 60. So 1.5 into 60, it will be the equal to amount in terms of gram. So my dear students, amount in gram, 1.5 into 60, 15 6 are 90, so 900, but there will be 1.90. So 90 gram amount of solute you will require, amount of ethanoic acid you will require, right? How many grams? Okay, in NEET examination such type of question has been asked. that we have solved. How many grams of ethanoic acid should be calculate number of moles, calculate amount of. And one more thing, let me tell you, my dear students. Students get confused with this term formality. Formality generally, right? Formality. Listen, you will calculate formality and molarity in the same way. You just calculate molarity and say that this is the molar formality for that solution. Why? Listen, if I am taking a solution 1 capital M of NaCl, 1 capital M solution of NaCl, right? That means if I will take 1 liter of such solution, it will contain 1 mole NaCl molecules. Now I have told you that the meaning of molarity. If the molarity is 1 capital M for NaCl solution, that means if you take 1 liter of such solution, it will contain 1 mole NaCl. That means it will contain Na molecules of NaCl. That means it will contain 6 into 10 to the power 23 molecules of NaCl, right? Now my dear students, you have written that it will contain 6 into 10 to the power 23 molecules of NaCl. How it can be possible? Because NaCl is a strong electrolyte. It will be ionized. It will be ionized to 95 to 99%. Suppose when solving numericals, we take that for strong electrolytes, there is a ionization 100% ionization for strong electrolyte. We consider 100% ionization for strong electrolyte when solving numerical portion, right? So if 100% ionization of NaCl strong electrolyte is taking place, so my dear students, if 100% ionization of NaCl will take place, so what will happen? There will be no molecule of NaCl. There will be no even a single molecule of NaCl, because all NaCl molecules will be ionized to Na plus and Cl minus ion. So there will be no even a single NaCl molecule in the solution. And you are saying that there are 6 into 10 to the power 23 molecules of NaCl. How it can be possible? Right? So you will just use the term 4 mole for the strong electrolytes. Where the solute will be the strong electrolyte, you will use the term 4 mole or formality. You will use formality. What is the formula for formality? Listen, my dear friends, what is the formula for formality? Formality is equal to number of moles, number of 4 moles upon volume of solution in liter, same thing. Now how to calculate number of 4 moles? Given amount in gram upon given amount in terms of gram, right, upon formula mass, right? What is the unit? 4 mole per liter or 4 mole liter inverse, right? It is a unit for the formality. How to calculate the question? How to solve the questions? Listen, 58.5 gram of NaCl is present in 2 liter solution. Calculate formality. It is a question that 58.5 gram of NaCl is present in 2 liter solution. What will be the formality for the solution, right? So see, my dear students, for formality you will use the formula number of 4 moles of volume of solution in liter. Number of 4 moles, you do not know the number of 4 moles, you will have to calculate the number of 4 moles, and for calculating number of 4 moles you will use the formula amount in gram amount in gram, it is 58.5 gram. And what is the formula mass? What is the difference between formula mass and molecular mass? No difference. No difference. You will see that NaCl, right? Na having 23 atomic mass, Cl having 35.5, you are going to add both of these value, 0.5538, 58.5 gram, right? 58.5 gram of solute, 58.5 gram will be the molecular mass of NaCl. It will be the formula mass. Molecular mass and formula mass both are same thing, but you use the term formula mass in cases of strong electrolyte, right? Just mass of one formula, right? So 58.5, that means 1 mole, 1,4 mole, na? You will use 1,4 mole here. So 1,4 mole upon volume of solution 2 liter, so it will become 0.54 mole per liter. What is the difference between molarity and formality? See, when you will calculate molarity for the strong electrolytes, you just use the term formality, but the answer will be same whether you apply the formula of molarity in case of a strong electrolyte. So answer will be same, you just use the same things, right? Same all these concepts, you will get the same answer, but you will say that this is not molarity, it is formality, because I have told you what is the reason for this. Because the meaning of telling molarity is that there are such number of molecules are present in the solution, but there is no even a single molecule that is present in the solution, because all are ionized into ions. So how you can use the term molarity? Because if you use the molarity, that means you are going to tell that if this number of molecules is present in the particular amount of solution, but there is no even a single molecule of solute, because it is strong electrolyte and we consider 100% ionization of the strong electrolytes in the when solving numericals, if it is not given, right? So my dear friends, that was all about molarity and formality. I have discussed various questions. I have discussed how to calculate moles of solute, how to calculate amount of solute in gram. I have discussed that how to calculate moles of solute in a mixture of two different solutions, how to calculate the molarity of a mixture of two different solutions, and I have taken different volume of two different solutions having different molarity. I have discussed about formality. So that was all about molarity and formality, my dear friends. If you having any doubt, so you can ask in the comment section. This is all about. In the next class, I will take the question of molarity. I will merge the question of molarity and molality in the same question. You will get the term molarity and molality. So it will be possible in the next part of this series of concentration. So the level of these questions is NEET JEE and advanced level. So if you are in 11th class and you are dealing with the chapter some basic concept of chemistry, so you can see, if you are dealing with the chapter solution and you are in 12th class, so you are dealing with the chapter solution and the topic concentration, it will be the second last topic of that chapter. So you can see these videos. So that was all about today's lecture, my dear friends. Thank you for watching.